All right, so in this one, we're going to talk about quantum numbers. So here is that relationship E equals h nu. They put it in this slide, but the main thing is just kind of know the limits of the values. So in the principal quantum number just starts at 1, 2, 3, 4, and the reason for it is that the energy it can't be zero because as we see in that Rydberg relationship that's above, then it doesn't make any sense if we have n equals 0. So that's why it has to start at 1 there. So the next thing is that L builds on top of it, and L can starts at 0 and goes up to n minus 1 in integer steps. So 0, 1, 2, 3. And so what we see is that when n equals 1, we only have L equals 0. When n equal 2, 0 and 1, and so on. And this is explaining the shape of the periodic table. The first row only has S. The second row, we have S and P. The third, we have S, P, and D. But the D isn't filled yet. It's not filled to the fourth. And that's why we have that n minus 1 relationship on the electron configuration I'm going to show in a minute. So the last thing that we have is that the MLs go from minus L through 0 to plus L. And so that's why it has that 2L plus 1 relationship. And so you can see it here. So all this gives us then the orbitals and all those kinds of things. And the last thing that doesn't come from the Schrodinger's equation is the ms, the spin quantum number. It's just observable that there's a spin state for it. And so what we get then is unique four quantum numbers for each electron in the different atoms. So hydrogen has one, so it has options. But then if we go to like lithium, where you have three electrons, we can see that difference in the electron configuration. So that's the other part of this, is it goes in with electron configuration. I like to reference the orbital diagram. I think this is the clearest in it. It's the most difficult to write, so we have those kinds of shortcut principles. So this zigzag then is only created to deal with that 3D. Why that 4S and stuff in 3D? So each time, so when n equal 1, we just have S. When n equal 2, we have S and P. When n equal 3, we have S, P, and D that's created, but it's not filled here. It's filled here. That's why this is 3D, where this is 4S and 4P. So that's how I like to kind of teach it. And so what we get then is a compressed view. And so we can do the quantum numbers, which are the least liked version of describing that one electron in hydrogen. And then, or we can write the typical electron configuration. And so, or we can do it from filling the orbital diagram. So for lithium, like I said before, it has three electrons, and we can see from the orbital, we have two in the 1s and one in the 2s. And so that's why we get this kind of notation. So these are the kinds of questions that you'll have. They'll kind of go with the electron configuration this way, and then how many unpaired electrons. I think I added that into it. If not, I want to have it added soon. All right.